In case you missed it, please revisit the recording which I have uploaded on my times. Okay. So the last week's practical recording is already uploaded somewhere here. Okay, so week 2 practical classes. So I have managed to record 2 sessions. So feel free to see any one of them. Okay, so that is an overview of what the coursework that is expected from you in this module. So what do we do today as a first practical class of MLPC? So we are going to introduce to some of the useful tools that you have to deal with and be friends with for at least the next 14 weeks. Okay, so we will be using an interface called Google Colab. Okay, Google Colab. So how many of you have used Google Colab before? How many of you have not used Google Colab before? Okay, right. So we'll do a quick introduction today on the first half of this session. And on the second half of the session, we will be going through some revision on EDA, exploratory data analysis, data wrangling, and also visualization. What are some of the important codes that it requires to do this task? Assuming that most of you have gone through some other modules, which is data science principles, data analytics, and machine learning. Okay, so we'll go through some of the basic principles to allow me to know roughly where you are and see if we need further sections on those areas. Okay, so let's get started. So today's practical, we will be introducing Google Colab to you. This is something that we want to work on very frequently, every practical class of every week. So we will also go through some best practices in terms of coding. How do we produce good variable names and how to make inline comments. Then finally, we'll do some revision on data dimension, columns, and also some important libraries to use when it comes to getting started with machine learning in Python. So setting up lab environment. So we are using Google Colab here. That is, it is very simple, which do not require extensive setup. It is an online platform. Okay. So what is Google Colab? Google Colab is an online tool for coding and also for data work. So it is an interface that is developed by Google that allows us to write and run Python code without any local installations. So we'll be using a web-based interface for that. Reason why we are using this Google Colab is because it allows us to get data from multiple places. Say, for example, if we have data sets which are saved in Google Drive or in GitHub, we can just easily connect this notebook to these places to call these data sets. Then another advantage of using Google Colab is it allows us to have access to CPUs, GPUs, and TPUs that is required to run machine learning tasks. Okay, so those are more powerful. So every time we run these codes on Google Colab, we are actually not relying on how strong our machine computing powers are. Instead, we will be connecting to a very consistent computing power provided by Google. Okay, so this is designed for machine learning and data science related tasks, and therefore it has to make this task easier compared to other IDE like PyCharm, Spider, and others. Okay, so what does this Colab offer? So it allows us to write and execute code in Python. It also allows us to document our code in a nice manner, in a nice notebook manner. So then it will also allow us to easily share this notebook for example submission, or for us to work with our teammate using a particular link that is created from this Google Colab. Okay, we do not have to send a file, the coding file, from one person to another. Instead, we will just share that link and everyone can just work on that same file. And finally, the best one is we have the access to free GPUs for a certain period of time. Okay, so now how do we get started with Google Colab Notebook? So let's use this link and try accessing to Google Colab. So this is a landing page where you will see a window that shows you where you want, that asks you where you want to open your notebook from. Okay, so say for example, you already have multiple notebooks, multiple codes, which is saved somewhere. This is where you can retrieve the codes. Say for example, you can easily retrieve them from your Google Drive or GitHub. Or in the case where any of your teammates, friends share with you .py files, or .ipynb files, you can also upload them here and read them in this interface, okay, in this IDE. So right now, what we just want to do is to start a new notebook. So once you start a new notebook, what happens? So it will link you to this blank canvas over here. That is our notebook that we will run our code, write our experiments. So what happens behind launching this notebook is that it creates a folder in our Google Drive called Colab Notebooks. So within this newly created folder, this notebook will be saved in that particular folder as untitled 26.ipynb, whichever name which is shown in your interface itself. Okay, so now how do we rename this notebook? Is we do not have to go to our Google Drive to rename it. Instead, we can just click on this and rename this to say this is my first MLPC notebook. Hit enter. So rename it only in front of the .ipynb. So this .ipynb defines the file type of this notebook. Okay. So once you set this in your Google Drive, it will also automatically update and refresh with your newly defined file name for your notebook, right? So next, another function that I want to share with you is on the top right corner. So on the top right corner, we see a share button. So this is how we can generate the URL link for us to share our files. So once we click on this share, these windows will pop. So this windows is trying to tell us that we are now trying to share my first MLPC notebook.ipynb with somebody else. So currently, the one that have the access to this notebook is you yourself. You will see your Gmail account here. So in the case where you want other people to access, you can type their email's address here. Okay? So this will share the file directly to them. There's also another way that you can share the file with your friends using an URL link. So this is where you can generate the link. You just click on copy link and you will generate the link that you can share with your friend. But do bear in mind that if you were to copy this link at this point of time with this configuration over here, once your friend click on that, your friend will not have the access to the content of the URL link. Why is that so? Because right now, by default, the configuration of the access is set to restricted. You are only sharing the content with restricted people. So how can you go about to change and the configuration of this access is clicking on this restricted, change it to anyone with the link. So now anyone with the link will act as a certain role. By default, anyone with the link serve as the viewer. So the person can only view your code. They cannot change your code. Okay. So now, if you want the person to work together with you on the same notebook, what you need to do is to change the role. So now say if you change the role to editor, your friend who has the link can now work with you together on the same notebook and edit the codes as you go along. Okay. So if you set the role to be commenter, your friend can only comment, but your friend cannot edit the code, okay, or the content. So this is how we go about with generating a link that would allow your friends to see it. So for the assignment purposes, what I require is at least my role as a viewer so I can view the code. So that is on sharing. Any questions so far? Very straightforward. So that is the two very important functions to get started with this Google Colab. So we just covered how to set the notebook name and how to share the file. So now we want to move towards the blank canvas at the middle of this Google Colab. So what can we do in this blank canvas? So in this blank canvas, we can do two things. We can write code and we can also write description stories. So how are we going to work with that is using the code blocks and also the text cell blocks. So these code blocks, clicking on this will add on more and more code blocks where we can type Python command and run the command. So if you were to use this text cell, it will provide us some cells which allows us to put in some descriptions. Okay, it can be in the form of paragraph or whatsoever. It can also be a list. You can also even insert some tables in these cell blocks. So the language that it takes in is a markdown language, whereas in the code blocks, it takes in Python language. So now say, for example, we just use a very common Python command, print hello world. And we do the same thing on the cell block. Okay, so now how do we run this code? First thing is we can run the code using this play button. So once we hit this play button, I want you to take a look at the changes that happens at connect. Okay, so once we hit on the play button, right now we are connecting to the CPU resources provided by Google. Okay, so once we are successfully connecting to the computing resources, we will see that the connect wording now changed to an icon of RAM and disk. So this shows that we are currently connected to the computing resources. Okay, so bear in mind that whenever we stop working on that, make sure that we detach this one from the resources because other people may be using the resources as well. Okay, we are sharing the resources, so be mindful and be considerate. So this is how we can run our code. So now say if we were to type the same thing, print hello world in the text block, it will just appear as text. So it appears as print bracket hello world inside the bracket. Okay, but whereas if we type print hello world, this is taken and read as a Python command which produces you an output of just hello world. Okay, so this is about code and text blocks. So how do we add on more text and code blocks? So using this button here to add on more blocks ultimately. Okay, so as many times as we want. So there's also another way that we can add on the code block or text blocks. Say, for example, we just want to add on a new code block underneath this code block. So we just need to hover over this box and wait until this surface. We say we want to add one code block underneath. So then here we get a new code blocks. Okay. So another thing that I want to share with you on the code blocks is pressing on the play button will allow us to execute the code. But there are also other shortcut keys where we can instruct these blocks to run the code using from our keyboard. So that makes our work more efficient. So these are some of the useful commands which you can explore after this class. Okay. So we have also covered how do we add on additional code cells. How do we change and delete the cells? Okay, so now say we have created multiple cells. And how do we rearrange this cell? Say, for example, we want to move this to the first line. What we need to do is just to click on the box that we want to move around. And on the right, you can see these buttons over here. We can use the arrow button to rearrange this cell. Okay. We can also use this bin icon to delete this cell block in case we do not want them anymore. So click on this and we will just delete it. In the case where we want to move multiple blocks, what we need to do is to click on the first one, hold the shift button to the next one that we want to move. So to select everything and move everything in one go. Okay. So that is on code blocks. All good? So next, we want to talk about the text cell blocks. So this text cell block, it is taking in the Markdown language. So what is Markdown language? We can just treat it as a simple typing, as in what we do in Microsoft Word or whatsoever. But using some symbols will help us to format the text in a more efficiently. So now say, for example, we just simply type topic 1. Okay, so this is how we want to get started. This is topic 1 that we want to do. In order to format this one, we can use the asterisk key. So if we wrap the wording between one asterisk, it will make the font italic. If you wrap this around 2 asterisks, it will make this bold. If we wrap this around 3 asterisks, it will make this bold and italic at the same time. Okay, so this is Markdown language. Of course, there are more useful functions of the Markdown language. Feel free to explore them. But today, I just want to introduce to you another important Markdown language, which will be helpful for our task or for our machine learning notebook. So now I want you to click on this icon here with 3 dots and 3 lines. So once you activate this one, you will see a table of contents. So right now, the table of contents is empty. So how do we add on the topics or the headings into this table of contents? So we will make use of the text cells with a hash key to do this. So say, for example, we just type topic 1. So now we want to add this topic 1 into our table of contents. We will add one hash key in front. And we are adding this into our table of contents. So now say we want to add another topic. Second topic here. We will just hash another text blocks. And now here, see, we are adding another table of contents. Okay. What is the use of this table of contents? It is very... Can I do it? Can I do it again? Okay. So I will add on another text block and say topic 3. Then I add a hash. There you go. Okay. So what is the function of this table of contents? So as we try to train models, it will make our notebook longer. There are certain parts where we want to train. There are certain parts that we want to test. There are also certain parts where we want to clean our data. So now, our code will just pile up to become longer and longer. So it is very troublesome if you want to retrieve certain parts, right? So if we have created this table of contents earlier, it will allow us to go to a certain parts very quickly by just clicking on them. Say, for example, we are now at topic 1 and we want to access topic 3. We'll just click on that and it will lead us to that particular blocks. Okay, so this is a very useful and important function. So the number of hashes that we add will define the level of headings and subheadings do we want to add. So now say, for example, we want to put this heading one level down topic 1. Say it is topic 1A. How do we do that? So one hash will make this topic 1A at the same level of topic 1. And if we want to indent this topic, we will just add on another hash. Okay, so this will indicate that it is actually a subsection of topic 1. Okay, cool. So I think that's all I want to share with you on the basic functions of Google Colab, on how do we create a quality notebook as well as the function of the code blocks. So now, in terms of saving our work, so I mentioned that once we started this notebook, it will save automatically. So it will auto-save in our Google Drive. So how do we then make sure that we save another copy as a backup, things like that? So we'll just use the file and we can save a copy in our Drive over here, or we can also save a copy in our GitHub directly. Okay. Sharing your work. I have already covered this earlier, so we won't do this anymore. And finally, on mounting Drive. What does mounting Drive means? Mounting Drive means how do we connect this notebook to access to our Google Drive. So what we need to do is just to go to this folder button. The first icon will allow us to upload any data set into this environment. The third notebook here will allow us to mount this notebook or to connect this notebook to our Google Drive. So once we click on this button, it will prompt us several steps so that we authorize this notebook to connect to our Google Drive, because Google Drive is a personal space. If we don't authorize it, this notebook cannot access any content from our Google Drive. So what we need to do is just to connect to Google Drive, and it takes several authorization steps. So on my interface here, it is connecting directly because I have done many sessions before these sessions. Okay, but you will just follow the instructions and you will get connected to Google Drive very easily. So once you see this drive over here, it means that we are connected and we can access to everything that we save in our Google Drive. Yeah. So now I mentioned that we get the access to powerful processing powers provided by Google. So how do we switch that? By default, this notebook is connecting to the CPUs provided by Google. So now say, for example, we just want to upgrade it to GPUs or TPUs. So how we can do that is we go to the menu bar, we go to runtime, and we go change runtime. So once we do change runtime, it will tell us that currently the code blocks is running or reading Python 3. So is there any other language that this code block understand? Yes, there is another language called R. So this is very statistical based language where we won't touch in this module. Okay. So then in the next section is where we can choose the computing resource that we want to connect to. So if you do the same action on your interface, you will see a different selections, because right now I'm using a paid version, and GPUs and TPUs are also available to the free accounts. So you do not have to pay anything. You still have the access. It's just that you are bound with a certain limit of time. Okay. This is about runtime, which I want to share with you. Okay. So yeah, we have just covered everything that we need to know on Google Colab. Is there any question? No question. Okay, cool. So the next section that we want to cover is some basics of what are the best coding practices on how do we write our code in a easy to read manner or in a tidy manner. So first thing first is we always try to create meaningful variable names. Say, for example, whenever we want to read our data set and save it in a variable, we want to make sure that this variable name is meaningful. We don't want to put things like A, B, C in a non-meaningful way. Okay, so if let's say we are importing our data set, then we just say this is a data frame, or we just put a name to the data frame. Okay, so that is the first part, meaningful variable names. So every time we name our variable, or every time we are naming our column of the table that we bring in, make sure that they are in lowercase letters. Okay, so this is one of the, so that it makes your typing easier in the future, because once we bring in certain thing and save it as a variable, we are going to use it again and again. So in order to make it consistent, as we don't have to cap anything as we type the code along, so make sure that everything is in lowercase so that it is simple to as we go along. Okay, lower letter. So in the case where we have a variable name which consists of two words, say for example, student name. So there is usually a space in between student and name. So we don't encourage a blank or a space in between two words. How we can go about with that is we can use an underscore to replace the space. Or there is also another way of managing it, which is using a camel case. What does a camel case mean? Camel case means we will be typing everything in small letter, but when the second word begins, we capitalize the first letter of the second word. If we have student name, it means we type student, S-T-U-D-E-N-T in small letter, and then name, we capitalize it, the N, then continue with small letter A-M-E. That is a camel case. Okay? So whenever we try to name the variable in our variable, we try to avoid these words such as if, else, while, for, because we know that it may be accidentally taken as for loop, while loop, or if else statements. Okay. So always remember that we want to be very consistent with our naming convention. Say, for example, if we are creating multiple models of decision tree. So the first decision tree, we name it as DT01. Next decision tree that we build, we want to name it as DT02, DT03, so far and so forth. So we don't want to name the first one to be DT01, the next decision tree to be DTLX, something like that, right? It is inconsistent. So make sure that it is consistent so we keep track of the total models that we have built. So singular nouns, what about that? So singular nouns means whenever we name our things, we try to use a singular nouns. We try to avoid the S or ES. Yeah. So that just helps us save some bits. So finally, there is also one more thing that I want to share with you, which is using hash. Earlier, I shared with you that we can use the hash button to hash key to create table of contents. So right now, that will only apply to the text cells. If we use, so now we want to introduce the use of hash in code blocks. So in the case where we want to comment on this code block, what this code is doing, we will use a hash key. Say, for example, this is just an example. So using this hash key in the code block will allow us to provide a small description to the codes so that the user understand what you are using, what you are doing. Or in the future, whenever you revisit this notebook, you also get a rough idea of, what am I coding this for? Okay. So in the case, so if we use a hash in the cell, in the code cell, this line behind the hash will not be treated as Python code. Okay? So in the case where we do not want this cell to run this line, We don't want to print hello world anymore. So we just hash this print hello world. So let's try running the code again. We will see that it doesn't run this line anymore. If we relax it, it will run this line. Okay, so that's all for best coding practices. And the next section that we want to do is a revision on exploratory data analysis and the pre-processing steps that it takes before we use our data set for machine learning purposes. I believe that you have read about this in many of your modules on what is really important. Okay, so now let's take a look. So what I need you to do is to download the data set from this link. So this data set is a very small one. It's a toy data set. Yeah. So for every lab moving forward, we will be using workbooks. Okay. So workbooks means I will create some activities which we will need to try after the class. You will need to figure out something to make sure that you understand things. If you are not able to do certain tasks, I do encourage you to ask in the following week. Okay, we will go through if we do not understand anything. So these practices or these activities is supposed to prepare you for the next section. Okay, so these are some of the very important parts before we get started with machine learning. I believe that many of the modules have give you some information about that. Today, we just want to do a quick revision. So let's go through the entire document of what we are seeing in the following 20 minutes. So in the part 1, we want to revise or take a revision on EDA, exploratory data analysis. Before we get started, how do we examine our data set? And what are the potential issues that we want to identify from the data sets? Okay, we know that data sets, they are messy, and how do we find them out? And what are the key areas to look out for? So I have activities like how do we read the data into Google Colab? So these are the expected output. And after this class, you will figure out the code to produce this output. Okay. You also figure out some of the code to display the data types. So we'll go through how to read this. Okay. Then how do we clean the data? So finally, before we end the class, we also want to cover a little bit on the chart types that is important to explore the data set before we run machine learning model. Okay. So yeah. Let's go through one by one. So now, a quick one. Before we go into coding or whatsoever, let's take a look at this small data set. So assuming that this is a data set that we want to train a machine learning algorithm on, try to tell me what are the issues that you find from these data sets. Incomplete data. Yes, there are missing values under age column where we see that, yeah. Yes. So Sarah has a missing category. Mike has missing age. So this is the first data issue and the most common one that we want to identify. Second issue. There are altogether 4 issues in this data set. Let's see if we can find all of them.
Price.
So someone said product price. Okay, there is a dollar sign. Okay, second issue is product price. Your friend have called that out. Why is there an issue? It's because there is a dollar sign in one of the input while no dollar sign in others. So this is an issue called inconsistent data types. Okay. So what is the impact of this dollar sign? The impact of this dollar sign is that we human we'll still read this as numbers. But as we read this data frame into this environment will accidentally treat it as an object because it sees some numbers and some non-numbers. This is a symbol. So once it sees a mixture of number and symbol, it will treat that as object. So there are 4 objects under product price, which is something that we do not want. Okay. So we got 2 issues here. First is missing values. Second is product price inconsistency. Third one, sorry?
Missing category.
Missing category. That's already covered in missing values.
Example.
Exam scores. What's the problem?
200.
Yes, that's correct. That's a good catch. So your friend here mentioned that under exam score, there is an erroneous values. So we know that exam score could be capped at 100 usually. And right now we see a 200. So this number is very suspicious. We can treat them as an outlier or wrong input. So that's a good catch. We have 3. And what is the 4th? Age. We have already covered missing age. Sorry? Yes, there's one more. One last one. Tips. Income. There's an issue with income. What is the issues? They are very consistent. There are no missing value, but yet there is an issue. Why? Because income. Yes, correct. So the problem with income is they are very consistent, but income is supposed to be a numerical values. But right now, the input shows that there is a mixture of symbols and new numbers. So we human will read it as currencies, values, but computer wouldn't take it as numbers. It is taking it as 4 categories. Okay, so they are treated as objects in this case. So if we want to use this as a numerical column, we will have to find a way to remove the $sign and also the comma from these values. Okay, so we have got all the 4 data issues. So you see the problem with data science is that whenever we have a small data set, it is easy for us to spot all these problems. But what happens if we have more than 1,000 rows? Are we going to run through this thing row by row 1,000 times? The answer is definitely no. And therefore, we need some EDA to process, to read, to find out the potential problem. So how do we do that is, can I have all of you to download that small toy data set from this link? Then I'll show you some of the ways that we can do this. Okay, let's download that. So once you download it, I would like you to launch a notebook, a Google Colab notebook. So once you launch the Google Colab notebook, what you do is you go to this file button. Then you use this button to upload the files, the part1.csv into this environment. So once you upload this file, do remember that this file will not stay here forever. Once we terminate this runtime, this file will get pushed out from this environment. The next time you want to work around with it, you need to re-upload the file to this environment. Okay. So once we upload this, first activity is how do we read the data into Colab and display the data frame. So now let's get started. So we will import a library called pandas and we will name it as PD. Okay, so we import pandas as PD. Then now, next, what we are going to do is, from this PD, this pandas is a library. It consists of a lot of pseudocodes. One of the codes that we want to use today, function today, is read CSV. So from this PD, we want to retrieve a function called read underscore CSV, and we want to read this file. So can we do that? So now, once we read this file, we will save this file into a variable called df. df stands for data frame. Then we want to initiate another line of this df alone because we have saved something in df. We want this code to display df. Therefore, we type df. So once you have that, try running the code. And you should get this output. Got it? Got it? Is there any error? Anyone have any error? No error, yeah? Okay, so once we read this, you can see that, okay, so now this data set is read as a data frame over here. So it has all the columns that we have in this data set with one indexing. So now the age is read as with decimal points, see? And the missing value here is read as NaN, not a number, not a number, okay? And the rest are just read accordingly, okay? So now next, we mentioned that it is very difficult when difficult to spot this problem when we have large data set. So what functions can we use to explore or examine this data set is these steps. We want to examine the data types of each column that we have here. So now we will use some code to produce its outcome. Yeah. So can I leave you to figure out the code? But anyway, I can show you that. But I want to focus, as I mentioned, this class, how do we read the output? Okay. So now, if we use a df.dtypes, so it will give us this output. So it is telling us that each of the column, what are the data types that this program now thinks it is. Okay, so now this program thinks that the name is an object. It means that it is a categorical column. The age is float. What does float mean? Float means it is a number with decimal points. So, which means it is correct. So then income. I think income here it is supposed to be float or integer. But right now, the program reads it as object. And we know the reason why is because of the mixture of symbol in that row, okay, in the input. So then product price is also read as object because one of the input has a mixture of numerics and also symbol. Exam score is defined as, is read as integer, which is correct as what we think it is. Category is object, so that is also correct, right? So this is how we can spot any data issues within our data frame using these data types, okay? So there is also another function that would produce more output for us, a more comprehensive summary. So I'll leave you to figure out what are the codes, but let's just go through how to read the output. So if we were to type some code, it will also be able to produce this output for us. Let's see what it is about. So we know that our data set is a very small one. We only have 4 lines of data, 4 observations, correct? And we have 6 columns. So what this thing tells us is that, okay, the range index is 4 entries. It tells us that there are 4 data rows that we have imported, which range index from 0 to 3. So the data column, there are a total of 6 columns. So for the first one, it is called the name, and there are 4 non-null value. What does this mean? So this summary tells us that there are 4 entries. We see 4 non-null. It means that there are no missing value in the name column. On the other hand, when we look at age, we know that we have 4 entries, but only 3 of the entries of age is non-null. It means one of the entry is null. So it means that we can identify the missing value in age. We know that there is one missing value, one observation with missing value. So when it comes to category, we also know that, okay, there is missing value, and the rest are 4 out of 4, so they are perfectly nice. Seems to be, until we examine the data types. So the data types will tell us that income and product price may have certain issues that make the numerical values perceived or read as objects, as category. Okay, so this is the purpose of EDA for machine learning. Okay. Yes. There are also some other codes that would allow you to find out where are the missing values. So please figure out how do we produce this kind of expected output. Oh yeah, sorry. I missed out one thing. So in this summary, we can see that we will be able to identify the total entry we have, whether we have any missing value. So this summary also provides us with the number of columns we have which are float. So this line tells us that there's one column which has a value with decimal points. One column is numerical with numbers with integers, no decimal point. And there are 4 columns which are categorical. Okay, and this is the total memory usage of running this data set. Okay, pick one. So today, after this session, go through all of this. These are the expected output. See if you can write some code to produce this output. Okay. So next, another important thing that I want to cover is important visualizations for this discovering the data distributions. Okay, before we get started with our machine learning, it is important to understand how our data behaves. So what are some of the basics? Okay, so now I have another toy data set which has only 10 rows. Feel free to download them from this link. First question under visualization. Which Python libraries are commonly used for data visualizations? So it's matplotlib and seaborn. Okay, matplotlib and seaborn. So now, under this matplotlib and seaborn, there is a function that would allow us to produce the statistical summary of the data. So I would like you to figure out how to produce the statistical summary of all the columns in this data set. Okay. Next question. So now say this is a very simple data set. We have the age of a student, the gender of student, the exam score of student, and the study hours of student. Okay. So now question is, what chart type is suitable to observe the distribution of age that would help us to identify any patterns or outliers? The name of the chart to display the distribution of age. We want to know whether the age is normally distributed or is it skewed. So what is the name of that particular chart type? It is called a histogram. Okay? It is called a histogram. Next question. What chart type is suitable to observe the frequency of each category? So now say, for example, we want to produce a chart that will show us how many of the input belongs to male, how many inputs belong to female. What is a suitable chart type? Bar chart, yes, that's right. Any other charts? Bar chart, pie chart, bar. Yes, correct. Is there any other charts? Well, bar chart is a perfect one. Or we can just simply use a frequency table to indicate how many classes is in each categories. Okay. Which chart type is suitable to observe the relationship between study hours and exam score? Say, for example, I want to know whether the more you study, the better is your exam score or otherwise. So what is the chart type that is suitable to observe this? A scatter plot. Yes, a scatter plot. Okay. So now, the chart type that is suitable to observe the comparison of exam score across different gender. Trying to see whether male or female, is there any trend in terms of exam score? Bar charts, right? We just have one bar that indicates the average score for male, another bar that shows female. Then we'll be able to identify the patterns, right? So the last one is the correlation between age, exam, and study hours. What chart type? So this is a heat map, correlation plot, or a pair plot. Okay. We shall come to that because this is something that is important for machine learning or regression problem. Yes. Okay. Okay. So that regression is a model. But right now we are discussing on what chart type, the name of the chart. So the name of the chart is a correlation matrix, a heat map, or a pair plot. Okay. So why is it important to know the name of each chart type? Because when we use this Python library to plot these charts, we will be calling out the name of this chart type for these libraries to plot that chart for us. Say, for example, if you want to plot a bar chart, we'll just use bar, bracket, something else. Okay? Whenever you want a scatter plot, we will say scatter or something else. Okay, so it is important to know the name of the chart types. So what we just covered today is how do we produce summary statistics, visualization, and the tools that it takes. Okay, so just now I mentioned that you are supposed to try it out and figure out the codes, right? So once you have figured out the codes, what you need to do next is check your solution with the sample solution that I provided. Okay, use this link to access to the notebook and see if you can get a similar code. Everyone can have different code, but this is just a sample solution for part 1 activity and part 2 activity. Okay, make sure that you are familiar with this before the next class. Is that all? Yeah. No, that is not all. So that is just the basics. So once we get started with the basics, I would like you to apply what you just learned on a real data set. So now in this self-learning task, what you will do is download this data set, load this data set, and also try to use the EDA, the charts, to plot some charts to try to understand what this data set is about. Okay, so this is a summary of things that you should try. Try to load the data set using the code that you have learned. Try to analyze the data types. Try to analyze the statistics summary. Try to display the count summary. Try to create correlation plot and summarize your understanding on the data set before the next class. Okay? So we shall conclude our class today and see you on Friday. Any questions? C. CSV instead of RSV. No, this one.
CSV. Oh, sorry. Natural language is in the next slide.
Oh, okay.
Yes, and we can't
Oh, okay. If you, yeah, can you try to follow the material and try to produce that? If you have any error, let me know and I'll come to you. Yeah.
How do I import the next?
How do you import the data?
Yes, I download it.
So now you can ask me because I am here. In case you cannot ask me, you can access to this one. Yeah, don't worry. So you just access to this one, and I got all the codes there. So you will see this one. Everything is here. Yeah. But if you want me to tell you, so now just want to make sure that you have already uploaded that file here. Have you downloaded? Okay. So let's upload them here. So once you upload it here, what you need to do is just to say r1.csv. Okay. So now we don't do two of this here. So we just do one of them. Okay, so we haven't run. Why is there an issue? Is because now we are trying to call this PD, but we have not run this code, right? So this environment doesn't know what is PD. Therefore, it produced an error. Okay, so now say, for example, we just go back and run this code. So we now import pandas as PD. So now this environment will know what is PD. We come back and run this code again. Okay, so there's still an issue. So pd.read CSV part 1. So let's see. It is probably not here. Bye-bye, good night.
Yes.
Bye-bye, good night. See you Friday. Good. Part 1.csv. It's supposed to be here. Okay, so now it has read this file. So now how do we display the data frame? So now we know that the data frame is saved in this df. So what we are going to do is say, tell me what is df, show me what is df. There you go. The data frame. Got it?
Now it has to mobile to change this one, right?
Yes. So now you will go through the document and see what are the changes that we should do step by step. Yeah. So like if you go through the document, this is a guided document. So say, for example, the first step is we have done the first one. Then next one is we should examine the data types. So how do we examine that? It takes some codes. So I have already given you the sample codes over here. Okay. So this is how it is to produce this output. And this is what it takes, df.info, to produce this output. Okay. So, but this one is a step-by-step guidance on how you should read and treat the data. Okay. So now just reading that EDA is about reading the data. Data wrangling is about how to change them from this one into this one. Say, for example, we know that exam score has an outlier. We just want to remove that row. So how do we do that? We will use some code.
So cannot randomly.
What if you have 10,000 row and you have 1,000 row with a problem? So you use code, right? Yeah, so now these are the codes. Okay?
Okay, that's more simple. Okay.
Yeah. So then how do you remove the dollar sign? Yeah. So these are some of the sample code that you can use to remove the dollar sign. How can you fill the missing values? With mean age, say average. So like sometimes we got missing value, we can just simply put one thing. Say for example, we just want to treat it as say this person must be average 27 years old. And how do we put the 27 into this row? Okay, there are also sample code provided to you. Yeah. It is somewhere. Fill an A with something else. Okay? Fill an A with the mean.
And then that means you know that a row has missing values.
Yes.
What if the row has multiple missing values?
It will fill all the NA with the average of all the input that it sees. Or you can also use like minimum value. Say you change this one to MIN to MAX, then it will use max value. So it depends. Yeah, usually we will use mean. Yeah. So yeah, that's all it takes. Then finish already. So all in this code. Then for visualizations, so how do you display the statistical summary? This is also provided in the sample code files. I don't think I have it open here, but I do have a document that provides everything. Yeah, but you just have to match this one to the code, everything to the code files. So say, for example, we have matplotlib and seaborn. We just discussed, right? And there are some description about them. So just read them. So you download the data set, do the same thing. So first step is how do you display a statistical summary?
So where to install those two to part two?
Sorry?
Where to import those two to do part two?
Yes, correct. So you just import matplotlib and seaborn. So then you read the data set. This is the same. So then you use a describe function to display the statistical summary. This is a statistical summary, right? Like what is the count, what is the mean, what is the standard minimum. Okay, this is called a statistical summary. So this is a histogram. We mentioned about how to observe the distribution of age. So we mentioned it is a histogram. So how to plot a histogram. Okay. Then what chart type is suitable to observe the frequency of each category? So maybe we can use a box plot. No. Each category. This is exam score. Frequency table. We can use this code to produce a frequency table for frequency. And which chart type relationship between study hours and exam score? So this is a scatter plot. Okay, scatter plot. Yeah. Then the next one, how do you display exam score different gender? We mentioned about bar chart. So this is how we plot the bar chart. Okay. Then relationship correlation. This is how we produce a heat map. Okay. And that's all. Then after that, what we do is this one. So apply all that we have learned to explore and analyze,
Practice. Eh?
practice
Alright.
on real data set.
Okay. Thank you.
Okay, no problem.